So profiling is an extremely useful tool. When I was working at EA Games, I did something to really mess up my frame rate, and I could not find it, and I could not find it, and I was trying to figure it out, and so I just put a profiler on it, and the profiler said, "Hey, this code is taking a long time," and so I was able to use the profiler to kind of nail down the problem child code, go fix it, and things were nice, and everybody thought it was awesome because I put a bug in the program and I took it out. For some reason, companies like to pay you to put the bugs in, and they like to pay you to take the bugs out. So there you go. Anyway, here's a profiler. It's going to take up some time in our frames, which is fine if we're debugging and developing our games. But if we're trying to release our games, we obviously are not going to look at the profiles on everybody's PC or console, whatever we push our game out to be. And we definitely do not want the profiler taking up time in the frames. All right? I've play tested some games for some companies, and their frame rates will go down real slow because they have all this debugging code running in the background, which is fine. You can still do a decent enough play test with some frame issues, but eventually, when you get closer and closer to release, you want your frame rates to fly, and you don't want your debugging code in the middle of it. So what we are going to do now is tweak our profiler class so that it will automatically vaporize out of all of the code in all the entire game. Wherever we use it, it will just vaporize and be gone and not take up any more time at runtime doing its computations. Well, how do you do that? It's actually not that difficult. You conditionally compile, meaning we're going to use the preprocessor. We're going to do what's called conditional compilation. That's the technical term for it. So we are going to conditionally compile out all of our profiling logic. Does that make sense? I hope that makes sense. So I hope that makes sense. Let me show you the issue. We are eventually going to go to our sandbox game and add some profiling in here. And let's just say, for example, and I'm totally just scratching this up just to kind of show you a little bit what's going on. But say we had our profiler, all right, and I'm going to go tweak that later. But say we had our profiler and I pound included it and all's correct. Let's just assume I have a profiler. And I want to say, somewhere in here I want to say profiler.add entry something, and it took this many seconds. Okay. Well, chances are we're going to have a lot of these peppered throughout our code, and if our game gets really large and we are doing a lot of profiling and we have multiple files, we're going to have all these add entries, add entries, add entries, add entries, so on and so forth. One way to vaporize the profiler out of your program is to go through and take all of those out by hand. Probably not ideal. Maybe it is ideal, but not convenient by any means. And say we want to do a build with profiling, and in another build we want to take profiling out. Well, now in some builds you got to go put all these profiles in there by hand, and in other builds you got to take them out. And that's going to be too much of a headache. So what we do is we conditionally compile this out. And there's a little secret. Basically, I want the compiler, when it sees me call add entry, I want the compiler to be smart enough to say, hey, add entry is doing nothing. So there's no point in compiling it in. Let's just vaporize it out. Pretend like this call site, that's what this is called, a call site, is gone. And so the compiler will literally just take this out for me. All right, well, how do we do that? It's actually quite simple. We make an add entry function like this, and we give it an empty body. And we also have to do it in the header file so that the compiler can see the implementation. If we stuff it away in our DLL down in our compilation unit for profiler, the compiler can't make any assumptions at that point anymore. But if we put it up here where the compiler can see, oh, it's an empty bodied function, then it will say, oh, well, this is doing nothing. Let's get rid of it. Right? I hope that makes sense. Well, you're probably scratching your head thinking, Jamie, we already have an add entry function. Well, yeah, you're right. We can't have the same function name with the exact same signature twice. That is illegal. So this is where the preprocessor comes in handy. I'm going to come down here and say pound if profile, I don't know, what should we call it? Profile logic How about profiling on? If profiling is on, then we want to compile everything in as normal. Alright. Pound else, or is it elif? Elif? There we go. Not if, just else. Forgive me, sorry. Pound else, they're not turning compilation on, so here you go. Alright, let me explain that. Again, this is preprocessor. It's important that you understand the preprocessor versus the compiler. Preprocessor is a separate step from compilation. Please go see my YouTube videos on preprocessing versus compiling in the C++ playlist if you need to be caught up with this. But essentially, since profiling on is not defined, then the preprocessor is going to tear this code out. It'll just take it out and the compiler will not see it. And the compiler will see this code. Alright, but if I go back, Control Z, bring that in, Control Alt L, let's go to our, we have to do this in all projects that consume this header file, which actually will be all three, but for now I'm just going to go here and say properties, and C++ preprocessor, and what did I call that? I called it profiling on. So I want to define profiling to be on, like so, put a semicolon there, and let's just do that with all projects. It's kind of a pain, I know, but let's do, oh, remember we used it for the testing logic. No overnight tests. Well, same thing with the profiling on. So profiling on, click OK, and then right here, properties, same thing again, profiling, oops, profiling on, semicolon, enter, enter. There you go. Now profiling on is turned on, so all that code will be compiled in. All right, but if I want to vaporize it, then I just have to turn this off, take it off. There we go. So here's key trick number one when you're trying to compile out a class. All the public functions need to exist without bodies. Or with bodies, sorry, with empty bodies is what I meant by that. So notice here, I'm going to put empty bodies on all of these so that the compiler will vaporize all and any call sites to these functions. It's also imperative that the functions return void, because if you call a function that doesn't return void and you're depending on that return value, well, obviously the compiler can't vaporize that. So it's imperative that all these functions return void. Okay, so there we go, profiling on. And then another thing is, if profiling is not turned on, then we don't need all this stuff for sure. We don't want to compile that into our DLL for our engine. All right, maybe I should have made a debugger or a debug DLL just for all the debug stuff we're going to do. I talked about that originally. Maybe I'll refactor to that. But anyway, pound, same thing, pound if profiling's on, then put all this stuff in here. Pound end if. Alright, I hope that makes sense. So if I turn profiling on to off, all this stuff will disappear. This is public, so I need to keep that either way, and it's just a static constant. So I think we're good. Control Shift B. Let's see if this builds. Build started, and you know what? The compiler is going to kind of make me feel good if this builds. The compiler will be like, "Yeah, Jamie, you kind of got that right. Good job." But notice the compiling's taking long. Oh yeah. Remember I had all these in here when I was demonstrating. I put all these add entries in here. Hold down Control Z. Very good. Now what I was saying over here was, if the compiler compiles and is happy with all this code, that makes me feel somewhat good. It kind of feels good when your code compiles. But what feels even better is when I can hit Control F5 and all my tests are green. Okay, that's kind of nice. Now, obviously my tests will fail. If I turn profiling on to off, they'll fail because these functions are doing nothing. So it doesn't make sense in the unit testing world to ever turn the profiles off if I'm doing my unit tests. So I always want profiling to be turned on, so to say, and that means it has to be turned on into my engine. You know, we haven't set up many. We're kind of getting to the point we need to do some build states, because we have various preprocessor definitions depending on what I'm trying to do. So maybe I should do a video on that soon. But anyway, let me just show you here. I'm going to go to sandbox game. Click properties. Anyway, so eventually I'll show you how to. I'll just show you an example. All we have to do is turn profiling on. We just undefine it, and that will vaporize. That'll force the preprocessor to put all this code in. Then the compiler will vaporize these the call sites out for these functions. So we'll do that when we're doing our game. We'll get back to our game, start using our profiler. The other thing we need to do is make our profiler a singleton, because I want this kind of a global one-stop shop, fills all. You can use the profiler for anything. I want to make it a singleton object, which means everywhere it's just there, it's available, you can use it, you don't have to instantiate it, and everybody shares the same profile or profiler instance. But before we do that, I actually remembered right here. So if profiling on is defined, and these are the function bodies, then we definitely do not want to double define the function bodies in the profiler.cpp's compilation unit. So I think the easiest thing to do there is to just say, hey, pound if define if def profiling on control end, enter pound end if control u. So hopefully you can see here, you know what, if profiling is not turned on, it's like the stuff in this file doesn't even exist. Right? So that's hardcore there, saying, hey, you cannot call that code because it is gone. Anyway, I remembered, or I noticed I forgot to define this or do this check here in the compilation unit. Let me just make sure this still builds. Control-Shift-B, build succeeded. Let's make sure that our test still succeeded. That's fine, and we're good to go.